we're going to do a little bit of review of the definition of derivative, and you guys will see why you need to know this for the AP exam. So it starts out, there are two definitions of derivative. So one we called the definition of derivative, and one we called the alternate form of the definition of derivative. Okay, so you need to know both of them. So if you have not already put these on flashcards, these are kind of important formulas, so you should know them. All right, so as a quick refresher, we're going to go ahead and find the derivative using each definition. So the first one's a little bit longer than the second one. So if I'm finding the derivative of x squared minus 3x plus 2, I know that you guys know the shortcut. I know you know it's 2x minus 3, and you can plug in 2 and easily get 1. Okay, but we're going to go ahead and we're going to do the limit as h goes to 0. I know, your fave. And then we're going to plug in x plus h, but I just want to do, instead of x, I'm going to do 2 plus h squared minus 3 times 2 plus h plus 5. And then I'm going to subtract out f of 2, which is going to be 4 minus 6, so negative 2 plus 5 is going to be 3. It's a little sloppy, I know. So we get that. And we continue to simplify, so we have to FOIL it out. So we're going to have the limit as h goes to 0. And we're going to FOIL and get 4 plus 4h plus h squared minus 6 minus 3h plus 5 minus 3 all over h. So we have the limit as h goes to 0. And the 4 minus 6 plus 5 minus 3 actually all cancels. So we have negative 2 plus 5 is 3, minus 3 goes away. So this, and this are now gone. Okay. So when we combine our h's, we have 4h minus 3h, so we get h plus h squared all over h, which becomes the limit as h goes to 0 of 1 plus h, and now we're able to plug in h equals 0. So now that we've cleared, like we've gotten rid of the h on the denominator, it's safe to plug it in, so we end up getting 1. Okay, so that was the long one. That's the one that I had to know when I was in AP Calc. All right, now the alternate definition is very similar. Sometimes it's easier, sometimes it's harder. In this case, it's a lot easier. So if I have the limit as x goes to 2, in this case, that was our a value. And f of x is just going to be x squared minus 3x plus 5. And f of a was what we found before. It's 3, right? That's just going to be the f of 2. So plugging in 2, you get 3. All over x minus 2. When you simplify, you have the limit as h goes to 0, and you have x squared minus 3x plus 2. Yeah, what did I do? Oh, I did h goes to 0. I just really love that h goes to 0 one, apparently, don't I? Okay, who got me on that? Okay, put your name on the board so I don't forget. Okay, so what do we do at this point? So limit as x goes to 2, we have x squared minus 3x plus 2 all over x minus 2. Do you guys remember from limits? Yeah, just factor it, right? So we're going to factor the top and the bottom, so we end up getting x minus 2 times x minus 1, and the x minus 2's cancel. So we have the limit as x goes to 2 of x minus 1, which now when we plug in 2, what do we get? 1. So we get the same thing. Okay, now the AP test, after I just put you through this torture, they're not going to ask you anything like that. They're not going to ask you to do that, but they are going to ask you kind of in the middle of the problem. Okay, so I have some examples of that because I did not do a good job of giving a lot of these examples previously, so I want to talk about these. So the AP test will probably have these in the multiple choice section, sometimes free response, but it will say things like, find the value of the following. And you're going to be like, what? Now I know that number one, you could actually solve using getting common denominators. You guys remember doing that? You could write 1 over 5 plus h minus 1 over 5. You could get common denominators and you can solve. Or you can recognize that it is in one of the forms. It's in the derivative form. Okay, so this is in the form f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. It's in that form. Okay, can you see what we need to identify what f of x is, and we need to say at x equals something. So what function do you think we're dealing with? Can you see it? Any guesses? 1 over x, that's exactly right. We're dealing with 1 over x. And what's the x value we're evaluating at? 5, exactly. Do you guys see how that's set up? Because if I had 1 over x, when I do f of x plus h, or f of 5 plus h, what I'm going to have is 1 over 5 plus h for the first part, minus 1 over 5 all over h. Isn't that what I have? Yeah, so we're identifying what those are. So what this represents then is the derivative, f prime. So can I find f prime when I have 1 over x as my f of x? Yeah. It's negative 1 x to the negative 2, or negative 1 over x squared. So can you find f prime of 5 then? Sure can, negative 1 over 25. That is the value of that limit. So you don't have to get common denominators and do all of that. You could just do it that way. Okay. Or this next one, like you don't have to multiply it all out. Add a divide by x minus 2. You can, right? You'll get an answer if you do that. But a lot of times these definition of derivative ones are crazy hard to multiply out. Maybe it's not raised to the 3, maybe it's raised to the 8th. Do you want to multiply it out then if it's raised to the 8th? No. You want to use the derivative. Okay, so here we go. So this one is not in the first form. It's not the h goes to 0. It's in the form limit as x goes to a, f of x minus f of a all over x minus a. And this one's usually very, very easy to identify what f of x is. So our a value is 2. Do you guys see that? What's f of x? X squared minus 6 to the 3rd, right? It's written right there at the very beginning. It's right here. All right, so what we're finding then is f prime of 2. So f prime of x is going to be 3 times x squared minus 6 squared times 2x. So we can easily find f prime of 2. We just plug in 2. So we have 3. 4 minus 6 is negative 2 squared times 2 times 2. So I get 4 times 4, 16 times 3, so 48. That's your answer. You see how these work? Let's try a couple more. So the next one, would we be able to solve this using limit rules? What would we do if we were just using our limit rules from chapter 1? What could you multiply by? Yeah, the conjugate. Multiply by root x plus 3 all over root x plus 3, right? So you could do that. Or you can recognize that it's in the form f of x minus f of a all over x minus a. Okay? So what's f of x then? You guys are so quiet. Root x, what's a? 9. Okay, it's in that form. So this is all going to equal f prime of 9. Can we find f prime of 9? Sure. The derivative of square root of x, you should all know by now, it's 1 over 2 root x. Or you could do 1/2 x to the negative 1/2. So f prime of 9 then is going to be 1 over 2 times 3, which is 1/6. So it's a little bit faster than multiplying through by the conjugate. Okay. All right, so the next one. So it's telling us our derivative f prime of 1 is equal to all of that, and it asks for what is f of 1/3. Okay? So it's in the form, so if you need to write it out, it's in the form f of x minus f of 1 all over x minus 1. You can verify, you know, if you have a guess for what f of x is, do you guys have a guess? What do you think it is? Cosine of pi x. What's f of 1? Does it equal negative 1? Cosine of pi times 1. Cosine of pi is negative 1, so we're good. Oops, that's really sloppy. Oh man, of course my eraser stopped working. All right, so that's negative 1. So that's why it was plus 1 here, right? Because it's minus a negative 1. So we have our f of x. Now this isn't asking for f prime or anything. It's asking for f of 1/3. So what we're doing is we're plugging in 1/3. So we have cosine of pi times 1/3, so pi over 3. So on your unit circle, if you have pi over 3, that's a terrible circle. It's like that. So it's going to be 1/2. So 1/2 is the answer. Does that make sense? Okay, so I'm going to give you guys a couple minutes. Try the next couple problems. I think there's 3 more. Are there 3 more? Yeah, try the next 3 with your table. right, so on number 5, it looks like the f of x is going to be the cube root of x, right? And then you're finding, well, you're just finding f, you're not finding f prime. So f of -8 then is going to be the cube root of -8, which should be -2. Did you guys get that? All right, so the next one, your f of x is going to be sine of x. So your x plus h is going to be the pi over 2 plus x. So we're at pi over 2 in this instance, which we have here anyway. And now it's just asking for f of 7 pi over 6. So we don't need to find the derivative or anything. We're just finding f of 7 pi over 6, which is going to be sine of 7 pi over 6, which on your unit circle is just like right there. So it's going to be -1/2. Do you get that? Yeah. All right, and then the next one, this was an actual AP question a few years ago. So if you have f prime of x equals the limit as h goes to 0 of 8 times parentheses x plus h to the 7th minus 8x to the 7th all over h. Your f of x then is going to be 8x to the 7th, right? And we're asking for f prime, so f prime, oops, that wasn't very, the eraser isn't working. So f prime of x equals 56x to the 6th. So f prime of 1/2 then is 56 times 1/2 to the 6th, which is going to be, let's see, 56 over 64, which reduces, how does it reduce? Yep, 7 over 8 is what we had. Yep. All right, and then the other one is saying, well, what's f of 1/2? So, does it matter if you have yeah, it's fine if you do decimals, but if it's a non-calculator, which you know how to do without. Yeah. So you have 8 and then 1/2 to the 7th. So we're going to get 8 times, do you guys know 2 to the 7th? Bigger than 64, 128. So you're going to have 8 over 128, or you can think of 2 cubed over 2 to the 7th, which would reduce down to 2 to the 4th, which I just wrote. So 1 over 2 to the 4th would be 1 over 16. So you could also do it that way. So you should have 1 over 16, and you should have 7 over 8 for your two answers. Okay, does that make sense? Do you guys understand why I made you do definition of derivative now? I know it was painful. I get